Alright everyone, I'm teacher EJ. Welcome back to our YouTube channel. Today, I would like to talk about a past year question from NMOS 2017, which is about the factor and multiple. Let's have a look. Alright everyone, so we know that Adrian walked on a circular region from starting point A. He walked along the path which formed angle alpha with radius OA and reached point B on the circle. So Adrian will start from the point A and move to point B. Then we say that the OA, which is the radius, will form an angle of alpha here. Alright, then he walked along the path which formed angle alpha with the radius OB when he reached the point C on the circle. So Adrian will keep moving to the point C here. And you can see that the radius O to B, it will also form the angle alpha. Then we say that by walking this way, when you reach the point F on the circle, the angle AOE is 36 degrees, which is this part AOE. So everyone, in this case, we say that by walking this way, what does it mean that? So you can see that when Adrian reached the point C here, we can also try to connect the line from O to C, which is also a radius. Then we say that this degree over here, it will also be alpha. Same goes to when Adrian moved from D to E. We can also connect the line, which is the radius OD. So this part will also be the degree of alpha. Same goes to this part when you go to point F, it will also be alpha, everyone. So in this case, we say that Adrian doesn't just stop here. He will keep moving. For example, we can also try to connect the line O to F. This is also the radius. Then Adrian will also move in the degree of alpha. Then it will go to the next point. Let's say this is a point G, right? The point G. So now we know that start from point G, Adrian will also move to the next point. We can connect the line from O to G. So it will move also around the degree of the alpha. So like this. So this part also be the angle, the degree of alpha. This is how Adrian moves, right? And then from the point F, we are asked to find the minimum number of times that he reached a point on a circle before he got to point A again. Alright, everyone. So now that we already know that how Adrian moved on the circle. In this question, how do we want to find the minimum number of times to reach the point A again? How do we solve this question? Any idea? Alright, so of course, if we try to observe Adrian move from point F to the next point, to the next point, to the next point, if you keep finding like this, I mean, it is very, very difficult for us to find the answer, right? So is there any other way? So let's observe our figures together. This line OA and OB, what is the relationship between these two lines? Both of them, they are the radius. So we say that OA is equal to OB. So if OA is equal to OB, what can we say about the degree over here? OBA. What can we say about that? It should also be alpha, right? This part is also alpha. And everyone can see that this part, OB, OC, OD, and OE, all of them, they are also the radius, right? So what we can say that this part is also alpha. This part is also alpha. This part is also alpha. So everyone, in this case, we know that all of this triangle, what can we say about it? They are the same triangle, right? Everyone. So now let me remove all the alpha first. So we know that all of the alpha here, they are the same, right? So we say that the angle in between DOE, DOC, all of the angle in between here, they are also the same, alright? Okay, so everyone, in this case, how do we going to calculate the degree? Any idea? So you see that this is a circle right here, so it will be a total of 360 degrees. So if this is 360, we know that all of these four parts, they are equal. So we just have to minus out the 36 over here, we divide it by 4. You will find that it is equal to 81 degrees. Alright, everyone. So in this case, we already know that all of this angle here, it is 81. Okay, let's try to observe together. So we say that for one point to move to the next point, it will be 81 degrees. Oh, so we can see that we start from finding which point we are moving, agent is moving, and then we change to this part. We know that each point is the rotation of the 81 degree over here. But in this case, we have to find from F to A. How are we going to solve this question? Now let me ask you, if I connect the lines from O to F, how are we going to find the degree from point F over to the point A? How are we going to find it? For example, this point over here, what will be the degree of this part? Everyone, because from point E to point F, this will also be 81 degree. Therefore, we minus with 36, it is just equal to 45. So you know that when agent moves from point F to point A, it must go anti-clockwise, like this, anti-clockwise. So to find out the degree, it will just be equal to 360 minus 45, which is 350. For agent to move from point F all the way to point A. But everyone, of course in this question, agent cannot directly move from point F all the way to point A, right? So in this case, we do not know agent will to go how many rounds of the circle, and finally it will reach the point A. So you know that for agent to go to F to A, it will be 315. And don't know how many rounds is there. We write it as n times already, alright? And each round it will be 360. So we know that F to A. So in total, we say that one point to the next point, it will be 81, right? So this summation right here, the result over here, it must be a multiple of 81. But everyone, in this case, although we know that this must be a multiple of 81, it is still a little bit difficult for us to find out the number of how many rounds over here. It is still hard for us to find it. Alright, let's try to think this question the other way. So just now we try to observe from point F to point A, and it is very difficult for us to find the answer. What if we try to change a bit of the question? You see that we said the agent walk on the circular region from starting point A. What if we try to change our question from the same point and at the same point, which is from point A to point A again? Everyone, so you can see that in this case, from A back to A, we know that each point, when we move each point, it will be a multiple of 81. And again, in this circle, if I want to go for A, turn again back to A, we must make sure that it will be a multiple of 360. So in this case, we say that from A again back to A, it must be a multiple of 81. It must be a multiple of 360. So we want to find a number that is a multiple of both of 81 and 360. What is something that we can find here? We find the least common fact multiple, everyone. So we have 81 and 360. Both of these numbers, we can divide it by number 3. So we divide it by number 3, you will get that it is equal to 27 and 120. And these two numbers, it can also be divided by 3, alright? Then you have 9 and also 40. Then for these two numbers, it is not able to divide anymore. So we have 3 times 3 times 9 times 40. And everyone can see that at this part, 3 times 3 times 9, it is just equal to 81 times 40. So this is the least common multiple that we find here. So we say that the least common multiple is 81 times 40. And everyone, do you notice that? Why do we need the 81 over here? Because we say that from one point move to another point, it must go 81 degree, right? A multiple of 81. Which means that at this part, for A to go back to A again, it will go 40 times of the 81 degree here. It will go 40 different points. But again, try to remember back. We say that we need to start from point F, everyone. So if I start from point F, how many points we have already moved? You can see that A, B, C, D, E, and back to F. So you have a total of 5 different points. So to find our final answer from F back to A again, it will just be 40 minus by 5, which is 35. And this is our final answer, alright? So let's summarize what we have learned in this question. So first thing, we say that when we have this kind of pattern finding problem about the point that appear repeatedly, what we can try to do is to find the rotation angle between the ascension point, right? So now you can try to do this practice question and you can leave your answer at the comment section below, right? So you may join our WhatsApp group for more information about our activity. I hope you enjoyed this video and don't forget to subscribe to our YouTube channel. See you in the next video. Bye bye.